All right, and here we are with our first addition problem in a different number base. We are using base 5, and so what we're doing is representing the chips individually. We have 143 base 5 plus 334 base 5. So as we go through, we'll just make our 143 on the top, make our 334 on the bottom, so that we can see both individual pieces. And then one way to do it is to just take the chips and stack them up so that each one represents one number. So we'll have each individual addend together. And so as you can see, each one is here. We have our 143 located on the left. We have our 334 located on the right. And in order to add them together, we simply combine place values, or like chips. In this case, that would be putting all the blues together, putting all the reds together, and putting all the whites together. Now when we're finished, we may have more than enough in one stack to regroup. So if we happen to have 5 or more, we could take those 5 whites, trade them in for 1 red. And if we happen to have enough reds, which in this case we do, we could combine those reds to make 1 blue. And then our final answer would be whatever we have in each place value. However, in this case, we have enough blues to trade them in for 1 green. So my final result, answer-wise, would be 1, 0, 3, 2, base 5. Alright, let's take a look at this problem one more time in a way that kind of shows where the algorithm tends to come from. So once again, we'll keep our same numbers. 143 on top, and 334 here on the bottom. Now, if we just keep each number intact and combine just in terms of place values, we'll put all our whites together. We can see there's 5 whites. They regroup into 1 red. And in a sense, that's the regrouping of 1, which maybe traditionally was called carrying 1. And now I'll put all my reds together. And again, anytime I have 5, I can regroup or fair trade, sometimes called compose. I'll take those 5 reds, trade them in for a blue. Put the blue in the blue stack. Now notice the whites and reds are fixed. 2 whites, 3 reds. I have enough blues to trade in for 1 green, so it moves over to the next place value. And my final answer is 1, 0, 3, 2, base 5. We can try another one, 2, 1, 2, 4, base 5, plus 2, 4, 2, 4, 3, base 5. And this time we'll have to use different colored chips to represent, because our whites, our blues, our reds, and our greens aren't going to get there. We'll need to go all the way up to black for this one. So let's make our first number. And then we'll need a little black piece here, a couple greens as we go, some blues, couple reds, and finish it off with our whites. So here's our 2, 1, 2, 4. 2, 1, 2, 4, again located on top. And 2, 4, 2, 4, 3 located on the bottom. So again, anytime I can make 5, I will do that. There's 5 white ones at least. I'll take those 5 and swap them in for 1 red, regrouping the red, leaving the rest of the whites behind. I've got enough for 5 reds. I'll trade those in for 1 blue, leaving the rest of the reds behind. Enough blues, if possible. In this case, there's not enough. But there is enough greens, so I'll take 5 of those green ones, trade them in for 1 black chip. My final result from this problem is 3, 1, 4, 2, 2, base 5.